Hello, today in this session we will discuss one sample t-test. See, I have got a file where question 1, 2, 3, 4, 5, 6 have been asked on Likert scale, where 1 is the least satisfied or strongly disagree, and 5 is the strongly agree. In between 1, 2, 3, 4, they relate to the satisfaction level. First, we will see whether these questions 1, 2, 3, 4, 5, 6 they are normally distributed or not, and then we will do the one sample test which will help us whether this variable is important or not. We will decide the hypothesized mean for each question. For instance, 1 to 5, the total comes out to be 15. 1 plus 2 plus 3 plus 4 plus 5 divided by 5. The mean is 3. So hypothesized mean is 3. So we will have to see whether this data is beyond 3 or below 3 and whether the variations are more or less. One sample test, t-test, will help us. In this video, we will use the earlier commands as we used in 16, 17, 18, 19, 20. So I will copy the commands from my earlier videos, earlier programs, and paste it, and just write 2 lines, one for normality test and one for simple one sample test. Let us go to Jupyter, the editor, which is going to help us to write the commands and run the commands. See, I have opened this one Python 3 editor with Jupyter, and we already have done the same things, say line chart moving program in program number video number 18. So we have written import Tinker as TK, import Pandas as PD, import Seaborn as SNS, import Matplot plot as PLT, TK inter import field dialog, from TK inter import all functions, from TK inter import TTK, and then window we are going to create TK, then win geometry is 7 into 5, and FP is file dialog, ask open file name. When after 3 seconds it will destroy the window, and then DF will be the FP file which have been saved, that will read, pandas will read, and then it will be columns, then all columns will be counted with the serial number. So we will just write down all these things, copy it. I'm just going to copy it, even I'm going to copy A as input. So I will say copy and I will put it in my new cell, paste. So import TK inter as TK, import pandas as PD, import Seaborn as SNS, import matplotlib. They are all functions. So they help us to do the things in a faster way. So input your choice for one sample test. One sample test. So it will ask you which column you want to do the one sample test. After that, we will write down the 2 commands. One more command we will have to write it, that is we can write it here as B. B is equal to input your test value or hypothesized mean, whatever you can say, hypothesized mean. So this you will put it, and then you are going to write two more lines for this. Uh, let us first run this part. Has opened a window for selecting our file. We will select the file as test3, which I opened it some time back. So it has run this and the file has been read. Our file is gender, cities, education, position, and this. These are the questions 1, 2, 3, 4, 5. They have numbered 6, 7, 8, 9, 10. And when we enter 6, it will automatically see the question number 5. Or if we enter 7, it will automatically see the question number 1, because the indexing starts with the 0. Now, after writing, we can write the choice. We can say question number 6, which is Q1, and hypothesized mean is 3, as I have already discussed with you. So now we can enter the two important commands, but first we'll have to say that A is your column. Which column? So I have written here x is equal to columns integer a minus 1, whatever a I have written it up here. Whatever a I have written it. So I have written it here, x is equal to columns integer a minus 1. So whatever a is comes, that from that we will reduce 1 and that column will be selected. And now B is your hypothesized mean. So we'll write down the two important commands. The important commands, first for normality test, we will write down the normality of x, because you have selected this A, which will be converted into x as column, is stats dot normal test. Stats dot normal test. This stats will come from the statistics. So the next one is one sample test result, which will be stats dot t test underscore one sem, which will be dfx and integer b. Let us run it. So we have to again select the file test3, and now we are going to select the question number 6, serial number 6, which is our question number 1, and hypothesized mean is 3. Now the results are normality of Q1. Because we selected 6, it's automatically saying Q1. Here we have written is x. Print normality of x. So it is coming as normality of Q1 is normality test statistics 32 point this. P value is 1.098, and see e minus 0.7. What does it mean? You'll have to put 6 zeros after the decimal. 0.00001098. It means it is less than 0.01. It means data is not normally distributed. Had it been more than 0.05, we could have said the data is normally distributed. Now, similarly, our one sample test results are statistics is coming as 17.48. That is t-stat is coming as 17.48, and the p-value is 0.000. See, 50 zeros and then 3. It is statistically significant at 1% level. Let us run an other variable, test3, and I am going to select now number 10, that is Q5, and hypothesized mean is 3. So similarly, this one is data is not normally distributed. another number from same test 3. Now we will select, say, question number 8, and hypothesized mean is 3. So data is not normally distributed because it is 0.005, and the p-value, it is say it is not equal to 3 even, because the p-value is less than 0.01 and less than 0.05, because this 47 means you will have to put 0.46 zeros before 3. This decimal 0.00046 zeros and then 3. That's the meaning of this. So normality test says data is not normally distributed, but we can use it with another file. Let us say run. I'm going to use now test 4, and I'm going to use it as number 2, that is age, and I'm going to take hypothesized mean as 25, means whether this is equal to 25 or not. So it is going to run, and we have got p-value of our normality distribution is 0.07. So we can say data is normally distributed because it is more than 0.05. So data is normally distributed. We cannot reject the null hypothesis. And similarly, this one is 0.87. It means this data, this p-value is more than 0.05. It means this we cannot reject the null hypothesis, that is mean equal to 25. This is equal to 25. This is equal to 25. Let us add one more command here, which you have learnt it already, plt histogram, and we are going to use this df same x, and we can draw that histogram. So you'll see run test 4, and we will have now select now age. So this age is, we are going to take it number 2, and hypothesized mean we will take 20 this time. So first we will see the whether data is normally distributed or not, then we will see the one sample test and histogram, same thing. So now histogram is there. Now it is saying data is, p-value is 0.076. Data is almost normally distributed, but the p-value is 0.0006. So this one is, age is not equal to 20. Age is not equal to 20. This one is to, because this is p is less than 0.05. See, earlier we have seen age as 25. It was not rejecting the null hypothesis. It says p is age is approximately, age is 25. But here, because we are, age is not 20. Age is not 20. So we have seen this histogram, though these values are more, one number is more than this one, but still the data is normally distributed because this normality test does not reject the null hypothesis. Thanks for watching. We will work on more programs next video. Thank you.